All right, let's say we want to find probabilities with data that is approximately normally distributed. So here we've got green sea turtles. We're going to say their lifespans are approximately normally distributed with a mean of 60. What that means is that for our curve, we can draw in 60 right in the center, and then our standard deviation is 7 years. So we can go down 7 and up 7 for each one of those hash marks. That's just counting out standard deviations. So 53 if we go down, 67 if we go up. Right, we can keep going back, so we can say 46, keep going up, 74. I'm not too worried about filling this out too much because we already have basically the span that we need. So we're interested in finding the probability of that a green sea turtle would live between 50 and 70 years. So first, it's a good idea to ask yourself, okay, where is that region? So 50, right, somewhere between 46 and 53 is in here. So you can mark that off as well if you want. So 50 is there. 70 is between 67 and 74. And so we want to find all of that region. Right? What's the probability of landing in that region based on this curve? So there are a few ways to do this. We can certainly find a z-score and use a table, but we have the technology to be able to kind of follow through on those steps in one fell swoop. So if we go to second and then vars for variables, above that we see distribution. So we click on that, and we notice we see a few things with normal right away. We want the second one, normal CDF. So if we click on normal CDF, depending on which calculator you have, it'll either take you to this screen or it will ask for these same elements. It won't label them, so you will have to remember the order that those go in. So the very first thing we want is the lower. What that means is the lower bound of the shaded region. This is why I would really encourage you to draw out a picture and get a sense of what does this region look like, not just for the lower and upper bounds, but also is the answer I get a reasonable one, right? We see that in this picture, a lot of the curve, right, the area under the curve has been shaded. So we should have a pretty big probability when all is said and done. Okay, so our lower bound for the region is 50. And then our upper bound for this region is 70, right? We're looking for between 50 and 70 years. Our mean in this case is 60, and our standard deviation, sigma, is 7. Now, if you did find a z-score for this, that's totally fine. You've standardized, but you would make sure that your mean is 0 and your standard deviation is 1. But for this, we're able to just use all of the raw data. If we paste that, to the left here, it just says normal CDF. You can scroll to the left to see that in your calculator. But if you have a calculator like a TI83 where you have to input these manually, again, it's lower bound, comma, upper bound, comma, mean, comma, standard deviation. So all 4 of those entries we would need to have. All right, if we hit enter, we're going to get 0.84687, etc. So this is, right, our probability of a turtle living, a green sea turtle specifically, living between 50 and 70 years. So 0.8469. I'm just going to round to 4 decimal places here. Remember, it gives this as a decimal, meaning as a proportion, but we can certainly change this over to a percentage. So 84.69%. If we're rounding to 2 decimal places, of course, we can go to more if we need to. And this is a pretty large percentage that makes sense with our visual. So again, it's always a good idea just to double check.